I have an hour, so should be all right. Um, all right, so I'm gonna try to go a little deeper into the components that Jose was talking about. So this is a deep dive into the Clinical Practice Guideline Implementation Guide. So we'll start with just an overview. It's going to be pretty high level, but I'm going to try to hit all of the components of a computable representation of a guideline in FHIR. And then we'll have Jing provide a demo and discussion about the Android FHIR SDK. Then Grace will give an overview of OpenMRS, and then Matt will give us a few words on approaches to FHIR CPG content with Gen AI techniques. So that's the link. It was just published STU2, and we have just rolled that dependency release through all of the smart guidelines infrastructure IGs. So kind of a problem statement to start with. Current state of the, oh, sorry, I should probably go into presentation mode. Sorry. All right, so a high-level current state. On the left, we see kind of siloed sequential implementation. You've got the narrative guidelines produced, and then those narrative guidelines are implemented in institutions by different teams that can't share their work. There's very little kind of feedback, inconsistent or non-existent feedback loops in that cycle. What we're going for in the FHIR clinical guidelines is a iterative and integrated approach, multidisciplinary approach that tries to move the informatics questions further upstream into guideline development. So those kind of ambiguities that Nat was talking about surface earlier in the process, and what we get from the guideline development process is more executable, more computable content. So we'll do an overview of the approach, kind of how we're thinking about representing clinical practice guidelines in FHIR, some of the key capabilities that approach enables, key deliverables for a FHIR CPG, and then what that looks like from the smart guidelines perspective. So if you think about the quality improvement ecosystem, start with research, systematic reviews, then develop clinical practice guidelines, so best practice. That's then turned into decision support that's applied at the point of care. Then we do measurement and analytics to try to understand how that worked. And then we do reporting through public health, quality reporting. And ultimately, ideally, that feeds back up into the research, and this creates a virtuous cycle or a learning health system. There are lots of different points of exchange across this ecosystem. And currently, they're using a lot of different exchange formats. So what we're trying to do is underpin this whole ecosystem using FHIR as the basis there. This is just to contextualize kind of all of the different work that's going on within different HL7 work groups. These are all different implementation guides. The slide is clickable if you want to dig into any of these. But these are all different specifications that enable exchange of information across these different points. So you have EBM on FHIR supporting research. We've got CPG supporting the computable representation of guidelines, CDS hooks and Smart App Launch to deliver content into point of care, quality measurement to specify quality measures, and DEQM to exchange those, and eCase reporting for public health reporting. The key is that all of these are using the same underlying FHIR resources to exchange that knowledge. We're going to focus today on this clinical practice guideline up here. So this is kind of a, I hope, non-controversial statement. Why are we doing all this? We want to reduce overall the development effort required for clinical systems to support evolving standards of care. There's a whole bunch of facets to this. We want to reduce duplicate effort while supporting innovation. We want to reduce inconsistency from setting specific factors. We want to reduce the accidental complexity so we can focus on the essential complexity that's actually happening. It takes many forms. We've got guidelines, you've got interventions, measures, documentation templates. Some of the principles that we're following in this approach are declarative versus imperative. So we want to focus on what rather than how. The separation of concerns, various types of independence like conceptual and logical independence. And the history of, if we look back at the history of computing, it's a history of raising the level of abstraction. So we move ever and higher levels of abstraction so we can talk about more declarative concepts. And finally, we recognize there's no silver bullet. These are hard problems, and we're trying to address them as best we can. So how are we trying to focus on that? How do we narrow down the scope of what we're working on? We want to enable precise and unambiguous sharing of clinical knowledge. So what do we mean by that? We talk about data interoperability. There are different types of interoperability. If you think about interoperability as a spectrum from data to knowledge, we build on layers of, and this is a continuum, not discrete, but we start with lexical. So on both sides of an exchange, lexical means we're sharing the same format, same characters, same symbols. Syntactic then builds on that, and you can't really get to syntactic without lexical. Syntactic builds on that to say we have the same structures, so we are organizing those symbols in the same way. Semantic then means that the values that we're sending in those structures are the same on both sides of that exchange. And that semantic interoperability is where you start to kind of get into knowledge interoperability. We're actually sharing not only the structure, but the meaning behind that. Then you build on semantic interoperability to actually get logical interoperability. If I know I'm dealing with the same semantic concepts, then I know that an expression in terms of those semantic concepts will give me the same result. So I build that logical interoperability, and then from there I can build process interoperability where I'm actually sharing workflow and orchestration. But these are layers that build on top of each other. I can't get to the next one without solving the underlying problem of the lower one. So overall, the approach is based on these levels of knowledge representation. So you hear the L1, the L2, this is where it comes from. So the narrative is human readable prose written in the form typically of a peer-reviewed journal article. Then semi-structured gets to things like flow diagrams, decision trees. It's more structured, but it's still not quite in the machine-readable characterization. Then L3 is structured, and in this context we mean a standards-compliant specification encoding logic with data models, terminology, code systems that's ready to be implemented. But it's platform agnostic, so it's a precise and shareable form of that knowledge, but it's not implemented in any particular platform. Whereas L4, executable, is actual CDS implemented, used in a local execution environment, actually running in a platform-specific way. So CPG then defines kind of a grammar for the kinds of things that we want to represent in computable guidelines. So we start with the data elements. The data elements are the data points that the computable logic needs. So if I've got logic and I need to run and make sure that I'm going to get the same answer, then we define the data elements and we use profiles in FHIR to do this. And because we're using FHIR, we can validate that if we give the data to this execution engine, if the data conforms to those profiles, then we know that we're getting a valid execution. Then we have activities. These are kind of the general kinds of things you can do within guideline-directed care. So things like order a test or prescribe a medication, provide counseling. These are just the units of work that can be performed in a clinical workflow. So this builds on the clinical workflow pattern in FHIR. FHIR defines a definition pattern, which broadly speaking means patient independent. So if it's a definitional, it's independent. A profile isn't defined for a specific patient, it defines what data looks like regardless of the patient. Then there's the request, which is patient specific, and that's broadly speaking things that should happen. And then there's events, and that's patient specific, and it's broadly speaking things that did happen. And note that these are very rough descriptions of high-level patterns. The specifics of any given resource dictate what's actually being captured and communicated, but these provide the general description of intent. We follow these patterns to give us a way to characterize an activity from the definition in the guideline, realizing that on a specific patient, and then carrying that out to a particular event. So here's some examples. Prescribed malaria prophylaxis. In the definitional space, we use an activity definition resource to say, this is prescribing malaria prophylaxis. Then when we actually realize that on a specific patient, that's a medication request. It's patient specific, it follows the request pattern, and then the actual dispense is the dispense resource. That's patient specific, and it's an event that actually did happen. Another one is provide counseling. Again, it's an activity definition. It's patient independent. Provide counseling to the client. When we realize that on a patient, that's a communication request. And then when it actually happens, we record that with a communication. So CPG defines for all of the different kinds of things you can do, send a message, collect information, prescribe medication. And this gives us the building blocks that we can use to describe recommendations. There's nuance associated with that. So in the definitional space, we define the proposals that we expect for a given patient. Those then get realized as specific proposals, and you might plan one of those proposals to do that later, or you might authorize that if it's a medication request, it requires authorization. So that's what the order phase is about, and then the actual event. So there's some nuance, and the FHIR SDK CPG provides a pseudocode for how the resources move through these different phases, and the FHIR Android SDK provides an implementation of that gives us a way to give application developers an easy way to deal with the results of a decision support call returning proposals. Next up is libraries. So then libraries are the reusable decision support and indicator logic. So here's an example. Jose was looking at this earlier as well. But these are expressions that are written in terms of those case features, in terms of the data elements required by the guideline. They make use of terminologies. They're organized to maximize reuse, so they have late contextualization. So we have an expression that has the MCV1 status, number of primary series doses administered, and that can be contextualized to an encounter or to for use in decision support, or to a measurement period for use in quality measures. So by organizing the logic in that way, we can reuse as much as possible. And these common expressions can then be reused across rules. They can be reused across indicators and even across SMART guidelines. And then there's common governance as well. So if you have a function that calculates BMI really well, you can propose that as an addition to the common library in the WHO common. And then finally, we bring that all together with recommendations. So provide malaria prophylaxis to a pregnant mother. So there's a condition in there that if the patient is a pregnant mother, then provide malaria prophylaxis. That overall then gives us a way to provide guideline-directed care. So applications then use SMART guideline content to obtain proposals based on the recommendations applied to specific patients. And these proposals are added to a care plan to guide the patient's care journey prospectively. And then they can also use SMART guidelines content to determine whether applicable proposals were followed i.e. became events and or outcomes achieved retrospectively, so we can look back in the record and determine whether it was adhered to. Okay. And then we can also look across a population for a SMART guideline, and this retrospective analysis then becomes an indicator or a quality measure. And that's the measure and measure report resources. The key aspect here is that these are, there are key interoperability resources in FHIR. There's, for the model, there's structure definition, structure map. For terminology, there's code system, value set, concept map. And for the behavior, there's libraries, questionnaires, activity definitions, plan definitions, and measures. And these are all FHIR resources, just like any other FHIR resource. And so they have, they can be packaged in implementation guides. So if you look at the kinds of implementation guides, CPG on FHIR is a specification IG that defines how to achieve a particular use case across domains. SMART guidelines are implementation guides that conform to CPG on FHIR. So every SMART guideline is a CPG on FHIR implementation guide or clinical guideline. And the key here is that they can also be shared. So I can have a WHO core or a SMART base that family planning, sexually transmitted infection, and antenatal care can all derive from and reuse content from that base. And what this gives us then is a guidelines ecosystem where you have, on the authoring side, you have guideline developers, measure developers, decision support authors, quality improvement agencies, and professional societies all producing guidelines content. A publishing ecosystem, FHIR package registries, terminology services like OCL and VSAC, and knowledge repositories like CDS Connect. That make this content available in a publishing infrastructure. And then on the execution side, decision support services, measure evaluation, EHRs, smart applications, backend services can all make use of that content to implement the SMART guidelines. So we've gone down a deep dive on CPG. The way these are organized in SMART guidelines then are with some SMART infrastructure IGs, SMART TS, that's common terminology used throughout SMART guidelines. SMART base is the core like SDC, CQL, and CRMI. Those are other topics. And SMART base clinical is where we introduce the CPG and encounter-focused content. And then SMART guidelines use those base infrastructure IGs to provide the actual content. So that's the overview. Now let's see how these are actually being used in some different software applications. You want to switch?
Thanks, Brent. All right, thank you. My name is Jing. I'm a software engineer from the Open Health Stack team from Google Health. So it's Brent's job to author the specifications, and it's my job to make it easy for developers to implement and use the specifications. So let's have a look at how we do that in Android in this section. A quick recap for those who maybe have not attended the OHS or Android FHIR SDK sessions. So the SDK is an Open Health Stack component. It's a set of libraries to make it easy to build apps on Android using the FHIR standard. One of the libraries in the SDK is the relatively new workflow library. So that's a partial implementation of the CPG-IG, which Brent has just described. It depends on the clinical reasoning libraries, which is authored by Brent's group in Java. But it also has integration with the FHIR Engine library and the Knowledge Manager library to load records, the health records, as well as knowledge artifacts to provide recommendations. So here's a sort of architectural diagram of how the workflow library works. It's quite complex, but basically in the middle you can see that uses the clinical reasoning module. It loads patient data from Fire Engine. It loads some of the logic from the knowledge manager, and it provides recommendations. But I've managed to simplify that for everybody. So essentially, you've got data, you've got logic, you've got some code that can apply the logic to the data, and that gives you recommendations. You are very welcome. All right. So taking a closer look at the APIs of the workflow library, we have sort of three main APIs. The first one is a plan generation API. So it creates the requests, as Brent described, by applying the guideline content. So we're talking about the plan definitions, activity definitions, and the similar resources like that to the health records. So that generates the request you can then sort of start using in the Activity Flow API, which is the second API. So the Activity Flow API implements the activity flow pattern in the CPG-IG, so that defines how requests should be carried out to become plan, order, and then eventually event. And then once you've carried out all these activities, finally you can sort of run the Measure API on device. So normally this is something you would do perhaps in the backend for obviously a large and complete set of data. But if you do need to run some of the smaller measures, I think you can still do that on the device using the Measure API. So putting this together, let's take a look at some of the example apps we have. We have two demo apps, both available in our repo. The first one is the workflow demo app. So this one uses the daily Apple IG authored by Brun. The IG is very simple. All it says is you should have an apple a day. Sound advice. So it generates the request, which is recommendation. And then you can see in the sort of video on the right, you can take it through the plan order and then finally the event stages with a simple button click. So it's a really simple demo, but it's actually really exciting. And I'm very proud of this because we have been working very hard to make sure that the APIs are simple to use and sort of hides the complexities from developers, right? So it really does a lot of work under the hood. It sort of coordinates the CPG requests and event resources in different phases. It maintains the references between the different resources and manages the intents and status, right? So the nuances that Brun referred to in the earlier diagram, a lot of that is handled by this API. And as a developer, you don't have to know everything about the CPG-IG, and we really do need to know is how to use this set of APIs. So referring back to I think one question in Jose's section as well, sort of how deep do we need to understand the IG? I think sort of having this level of infrastructure and library is a very important component of the ecosystem to enable and accelerate implementation. Right, so this is a more complex example. This is the Smart Immunizations demo app. This is something we created actually last year in a previous meeting. So this uses content from the WHO Smart Immunizations IG. I need to caveat that we're not using the latest version because we haven't really tested that yet. So it's a more complex IG with a lot more resource types. There's questionnaires, structure maps, logical models, and plan definitions, multiple plan definitions in that IG. So what the app is doing here, as you can see, it sort of carries out the entire flow of registering a new patient and then applying the plan definition on the patient data to provide a immunization recommendation. And then it takes that immunization recommendation all the way through the different stages of the workflow. As a health worker, you could input more data. You could sort of assess the contraindications that might exist for that patient. And then when you are getting to the point of actually administer the vaccine, you could also input the batch order, more details about the vaccine that is being administered, and then eventually that completes the entire workflow. Oh, I think maybe the GIF file doesn't play till the end. Yeah. I can show that video actually. Let's do that. I hope this works. Fredo, how's your hotspot holding up? Here we go. Right, so as you can see, it's going through the patient registration. Yeah. So and then you can see that it's generated a immunization review task, which is a proposal, and a different questionnaire is then being loaded. So once you have completed the questions in that questionnaire, the proposal will be taken to the plan stage, and then you can sort of input the contraindications for the patient, and then when you're administering the actual vaccine, you need to input some more data about the vaccine date and time and the batch number, etc., etc. And the video stopped. Okay, it's going again. Yeah, just to reiterate, it's really taking the content from the IG and being able to use simple APIs to apply that to the health records you have. Right, so we think this is really significant for helping developers to be able to use the content authored by the experts and WHO smart guideline groups to take the deployments and implementations to the next level. Thank you very much. And we have Grace from OpenMRS next.
Cheers. How are you all doing? So if I was in your shoes 2 years ago, before I had smart guidelines experience myself, right now I would be like, So I'm going to walk you through how I came to understand smart guidelines and how we came to understand smart guidelines in general at OpenMRS. If the demo gods like me. It's not just about the slides. I was hoping to show you some things live. But that's always risky, isn't it? I don't know. Can I try a new connector? Okay. Yeah, sounds good. There's 2 links I wanted to open, but that's okay. Yeah. Yeah. Be hard to find. Thanks so much, Jing. Okay, for real this time. So I'm going to walk you through our journey as OpenMRS over the last 2.5 years in how we're thinking about decision support for better care and what specifically FHIR and smart guidelines mean for that. a bit of my background. I'm Grace Padma. I'm director of product for OpenMRS Inc., which is like the foundation of OpenMRS. We support our worldwide community. And now, before I joined this global goods community, I actually worked in private healthcare software. And I used to write, I used to be a nurse, an emergency specialized nurse in critical care. So I used to lead a team of doctors, nurses, and med students, and we would actually write care plans using a proprietary UI. And all of this was fire care plans. So I have actually seen 6 years ago fire care plans working really, really well for decision support. So this was no surprise to me that this was something our industry ended up looking into. So in OpenMRS in general, one of the things we have to do, we're a medical record system, but all over the world, many people want to customize and configure. We have worked really hard recently, just in the last 4 years in particular. If you've seen OpenMRS from like before the last 3 years, you probably haven't seen the new OpenMRS. So in the new OpenMRS, we have a lot of guidelines on how things should look and feel, and that includes decision support style things, like alerts saying, hey, you need to know this information. Hey, Grace is due for a viral load, etc. Hey, Grace might be pregnant, or hey, Grace might be at risk for preeclampsia, or Grace is due for a vaccine. So when you put all of this into the patient chart, you start to see things like flags, things that have must-know information. Hey, Grace is at risk for preeclampsia, as well as nice to know, tasks, and so on. But a real big risk, there's different workflows that can trigger these things, but a real big risk we're trying to mitigate is alarm fatigue. So amidst all of this, the problem is, as we've heard from our other speakers today, how do you get this great content, like preeclampsia screening risk, for example, into a system like ours quickly? It's taking too much time when all we have are PDFs, hence the SMART guidelines. So how do we get to something like this faster? And that's really what this comes down to. So the way I encourage everyone to think about SMART guidelines is as a recipe to make this stuff happen. Now let me talk you through this recipe. Who here cooks, like ever in your life, even once? Okay, has everyone ever used like baking soda or flour? Okay, the men in the room like, these are your baking ingredients. First, we heard from Bryn earlier about how you need data elements or terms or concepts, terminology, etc. We also know you need forms like what we were seeing demoed. We need to collect the information somehow. Then we need a way to write the rules in the software to say, if this is true, please screen Grace for preeclampsia. Then we need a way to actually calculate those. You might write the formula, but you still need a way to think through that formula. And then, of course, at the very end is like what I just showed you. You need a user interface to say, Dr. Grace, wait, look at this. So for all of these ingredients that you need, there are different tools available, and we just heard about many of them today in the last 2 days. So the one that we've been using in OpenMRS, which is a global good called OCL, which stands for Open Concept Lab. They host a wide variety of any kind of terminology system, whether it's ICD or CL or others as well. We have our own form builder, as well as, so that's the only custom thing here. Everything else that you see here, these are all open source projects. So what I'm trying to say is the ingredients that you're working with are the things that you're hearing about today, like FHIR, as well as the CDS engine. And I'm gonna explain this a bit more as we go on. So the good news for OpenMRS implementers, or any implementer in general, as terrifying as the SMART guidelines might be feeling right now when you look through all the FHIR structure, you're actually already used to doing most of this stuff. It's just that you're learning to work with some new ingredients. There's a new brand of baking soda, for example. So forms, concepts, or terminology, and the business logic of how we get this done. So how do you set up all these materials you'll need? I'm gonna walk you through what it looks like for us at OpenMRS to set up the forms, concepts, and then the stuff we need in the brain to actually execute these rules. So forms, not gonna spend much time on this, but we basically built a user interface for people like myself. I really don't enjoy writing JSON. Commas are the bane of my existence. So I prefer using a user interface as a nurse to quickly design and edit forms. But the biggest thing about building forms is that you need the right data elements behind those forms. So most of our time ends up being spent on the codes. And this is where I'll briefly talk about Open Concept Lab. Who here has seen the DAC, a DAC spreadsheet that has the different like data elements, like HIV positive is 1, 2, 3. Who's seen that? Put your hand up nice and high. Okay, so if you haven't seen it, please talk to one of the people who put their hands up. That was what I was going to show you here. Because it's not as intimidating as you might think. So in the under the hood of OpenMRS, this is what high blood pressure looks like as a code. So it has a unique ID, but then it's also got, notice something special. Do you see all these mappings here? So now if we plug in a bunch of rules to run, and the rule is encoded using something from Smart Guidelines or something from SNOMED, it will know that this data element is relevant because of that connection, that mapping. Making sense? So the mappings are really important, and we ran into that when we were using the antenatal care DAC, or the L2, the spreadsheet with all these data elements. We were using our own coding system, an open source project called CL, for something like high blood pressure. But in the DAC, there are DAC-specific codes for things like severe hypertension. So we were able to really easily use this tool, Open Concept Lab, to tell ourselves that these two codes are the same guy. Making sense? So I highly recommend that. Okay, now this is all going to come together now. So let's talk about the other building blocks you're going to need if you're trying to do this stuff in a system like OpenMRS. We have a module that allows us to connect with Open Concept Lab so that we can learn about all those mappings. Then we also have a module that unlocks those flags that you saw earlier. Yesterday, I spoke about the FHIR2 module. This is a module that we built that plugs in to an existing OpenMRS system to allow your system to understand FHIR and share FHIR. And now I'm going to tell you about this new module that we worked on called the CQL module. CQL stands for Clinical Quality Language. This adds an open source project into OpenMRS so that we can consume these structured rules. Let me explain what I mean. So yesterday I talked about FHIR and how you can connect FHIR understandability into your OpenMRS system. There's some more information there if you want to learn about it. But I want to tell you about the brain. So we've now got our data elements, we've got the terms and the codes, and we've got our forms ready to go. We've got our user interface figured out, but how do we actually crunch these rules? How does the system do the math? And that's where the rule engine comes into play. This is going to look a little intimidating, but I'm going to walk you through this. So we took a module, or we made a module out of this open source project called CQL Evaluator. It basically takes rules that have been written in the FHIR care plans using the clinical quality language syntax that basically says, if this is true, then Grace probably has preeclampsia. So this packages it in a way that can be added to OpenMRS. I'm just going to zoom in so you can see what's happening here. So then we were like, let's try it. There's lots of ways you can do decision support in any global good, including OpenMRS, in a custom way. A lot of people around the world using OpenMRS do have decision support alerts popping up today that say, hey, wait, Grace is due for a viral load test. But most of those rules have been written in a custom way for every site. So the vision here is that you would be able to say, I really want the ANC decision support number 17 added to my system. That's the rule for preeclampsia screening, if you don't know. And so the idea is that with this module, you basically plug that rule in. That's the vision. So this is what we tried out. And adding the CQL module makes this possible to digest these rules that are being published in L3 in a structured way. And then this is where we had some learnings. The first thing that I'll say is when we did this at first, we ran into some really serious performance issues. Like it was just taking a long time for the engine to think. And it's like, is Grace pregnant? Taking way too long for point of care. However, since then, this is a real testimony to this community. Folks like Bryn and Jing, they actually really took this on themselves and drastically improved the performance over the last year and a half. But there are two things that we still want to figure out in order to implement smart guidelines. So the biggest thing that we're trying to figure out right now is how do we make sure that developers and others can encode their rules in a structured way that is easy-ish to learn, but also sustainable, because we know that most of the developers or programmers that use OpenMRS, they're already under tremendous pressure, often unrealistic pressure. And so asking them to learn a new language is kind of a lot. We have also seen, particularly over the last 2 years, since we started encouraging folks to use Open Concept Lab, suddenly all these data elements that were kind of hidden underneath stuff that developers could read, but not people like me, not clinicians, not BAs, we've suddenly discovered that many organizations have had a lot of wrong mappings. And so it's really important that, you know, a mapping in the past could, if it was wrong, it could mean that your report is wrong, your numbers are wrong. But now if we're doing decision support, if you've done the rules and the mappings wrong, suddenly you could be giving clinically dangerous advice to that provider. So it's really, really important that we figure out how do we make it easy for someone like me or a clinician to double check that the way the rules have been written is safe. Because often when I write like a DAC and then I hand it over to a BA and then they hand it over to a dev and then the ministry asks for a change and then another change, along that way, it's like a game of telephone, and it would be easy to introduce errors. So these are two things that we're working to figure out, and this is the community that's helping us do that. So it's actually a really positive thing that we're all here. And this is what we're currently working on before we recommend using this technology directly in production. But in the meantime, you can still continue to implement the SMART guidelines, just using some custom ways of representing that data. So more work to do, but this has been our journey. Thank you so much.
See if I can make this work. Hi, everyone. I'm Matt from ONA, and I'm just going to talk to you quickly about some exploration work we've been doing around using Gen AI to author content in FHIR. So just as a reminder again, just to hit the point home, L1, L2s are the normative guides. So this is kind of like, comes from your Ministry of Health, comes from WHO, this is what you need to put in the app. And typically the task today is you have to get that, and then you have to work with some programmers, and then at the end of the day, you get the L4. What we're trying to talking about today is how do we use that L3, using standards-based content and logic to create applications that can run this. So the idea of reusable content, so today I'm talking about how do we author the L3 content that can be reused on applications that are L4s. So Gen AI, we think really has an important opportunity to simplify the development of these applications. And you can think of SMART guidelines as another way just to say an app in FHIR or a FHIR app, because it defines your logic, it defines your forms, your data model, but also we've hacked it with OpenSRP and OHS to even allow you to define your UI also using configs in FHIR. So that's just kind of a quick thing. So this is still kind of early, but I just want to show you a little bit of an exploration work we've done. So this is the day that O1 preview came out on ChatGPT. So I said, you are a FHIR expert. Please follow the WHO guidelines to author a questionnaire. So this is basically zero-shotting from L1 all the way to the L3. So I didn't even give it the WHO guidelines. I just said, based on your knowledge, author this thing. So it authored the thing. Sorry, it's going a little bit quicker than I thought. And it authored the questionnaire, which I'll show you in a minute, but it also added extensions for things like EDD, expected delivery date, BMI, et cetera. So then I took that questionnaire, which it authored. And again, a questionnaire is the way in FHIR that we author forms. It's like an X form if you know ODK. I loaded into a form preview tool. So this is the tool that it authored, kind of out of the bat. There's obviously some improvements we can do, but you can see it's kind of getting all the right questions. If I gave it a bit more guidance, I can make that like a pull-down list or multiple select for the illnesses, et cetera. But it's generated a pretty good form with all the things that you would expect in an ANC registration, including some of the family history, social history, et cetera. Now, the next thing that is a real pain if you're building applications in FHIR is writing structure maps, which my team can tell you. So structure maps are the way that you extract your data from a questionnaire response. So here it's basically saying map the demographics to the patient resource, map the abstractic data to the conditions in FHIR, et cetera. So it's basically in 21 seconds taking the form from that questionnaire and based on its knowledge of FHIR, map these out to all the different questionnaires, to the different observations and resources in FHIR using it. And lastly, so that's done the data extraction part. And that's something that if manually with an analyst on your team or an engineer, typically like a junior level engineer, you would spend a week or two doing that manually because the authoring tools aren't great yet. And then here I'm showing you just the questionnaire response, this is the questionnaire. And you can see that it's done the LMP date properly, the expected delivery date. So it said, take the last menstrual period and add 280 days. That's when you would expect it to do. So it has all that kind of clinical knowledge built in. That's not without even referring to like giving L2 knowledge or L1 knowledge from it. So I think it's quite powerful what's possible. And then just kind of lastly, just kind of for fun, I asked my team to start playing around. So this is OpenSRP. This is a code tool called Cursor. So it's an AI augmented authoring tool. And we took our immunization app that's based on the WHO SMART guidelines. And I said, hey, can you add an HBV module? So basically, if you see here, these are like the instructions that we're following. The right side is basically the chat window. And it starts prompting and updating code. So what I've done here is you can see that we've now added an HBV screening test to the thing. It's generated this form for HBV screening, which you can see here. So you can fill that form out. Now we just registered an HBV, so basically an adolescent girl, or now I guess teenage boys too, for HBV. And then if you zoom forward in the video a little bit, we've now also added the register. So here you can see there's now an HBV register added to the application. And you can click, and then this is started using the FHIR logic that we have built on top of OHS in OpenSRP. You can see the child if I click on it, I think. So clicking on the register, I can now see the child shows up. So it's been filtered. That child has received HBV, so they're now in the HBV thing. We could do follow-up, et cetera. And then we say shits and giggles in America, or craps and giggles, I don't know what you say. I said, hey, can you have it translate the application to Spanish? So now if you look on the right side, it's now translating all the FHIR resources to Spanish. And now I have an application if I switch it. So you see that's on the right side, the LLM's working, and it's doing all your translations to Spanish. If I fast forward a little bit, you see now we have an application in Spanish. So again, this requires QA, it requires a lot of things, but if you are like somebody already understands FHIR, it dramatically reduces the barrier to entry or your time in being a developer. Also, if you're new to it though, it's like I'm not that technical anymore, I used to code, but I can look at a questionnaire, I can look at a structure map and see if something doesn't look like it makes sense, if I see that pattern. So it's easy to edit if you're not a technical expert, and this gives you a great first pass from it. So the nice thing about FHIR being standards-based is there's a lot of information out there. There's a lot of really good documentation on what FHIR should be authored like, so LLMs are good at writing it. So I think one of the questions for me is, should we be spending a lot of time as a community authoring L3s? Or should we just be creating the best possible instructions to give to an LLM to help us author the L3? So the L2s might become more valuable in the context of, because right now, one of the challenges in our space is it takes a lot of time and money to write really good L3s. So WHO is investing a lot in the L2 authoring, which I think a lot of countries have already invested in. So if you give this LLM, your data model, really good instructions, I think we'll find that the AI authoring could help us do that translation for us. Since the whole point of an AI is being a transformer of knowledge, so transforming from L2 to L3. Early days, but I think it's quite promising. And we think the last point is a lot of the tools right now, if you look at like DHIS2, these other tools, they're popular because they make it easy to author for somebody non-technical to author the content. The challenge with FHIR is you have to be a lot more technical. But what you can get out of it is something much more powerful that you really can't get in a no-code tool because the logic is just going to be too simple. So I think the bridge between code, which is the best way to represent logic, and something where you want something no code that's much simpler, is maybe AI that can make that process a lot more accessible to non-technical people. So validation will be really important, a lot of other things to make this more usable, but I think it's really promising. Thanks.
We can take some questions from the audience.
Hi. This is great session. This may be a very self-evident question, but I think I'll ask it anyway. Has the WHO team provided any kind of simple guidance around the roles, the skills, the number of SMEs for someone to actually construct or customize, if you will, adapt one of these for a single CPG? Because frankly, that's the only next step between being able to go from here and then actually getting people involved and engaged. So the ministries need to understand that in terms of the resources they need to bring to bear. But that would be a very simple thing to do, I think, and very, very effective in helping people get started.
Natasha, do you want to? Or
Yeah, I can answer that. So we do have some template TORs that we've developed for key roles. But in terms of like how big a team would go into that is highly dependent on the context, because you could have someone who could do all of it by themselves. I mean, it's not recommended or likely, but it's still possible. Or you might have a team that you want to build up, and you're effectively having two companies working together to then build the capacity of the other one. So it's not really straightforward as, okay, here's the L2, here's an L3, here's the exact team you need to do it, you know, and you're done. I think that would be an oversimplification of what actually needs to happen. Any other questions?
Yes, I have a question, to Dr. Grace. On the question of the clinical decision support, wanted to know her experience on shared decision making, because the paradox is that it's the complicated patients who need decision support, and most likely they don't have just one thing going on. Studies have shown that for the simple patient, you just need 2 to 10 data points, and you arrive at a diagnosis and it's done. But as you go to the more complicated patient, it goes to the hundreds of decision points. So how do you handle that, especially on a latency point and on shared decision support systems?
Grace, I'll have you take that.
I think that question was for me, right? Yeah. Okay, cool. Well, let me start by saying, does anyone here watch Formula One? Everyone familiar? Have you ever seen decision support alerts pop up on their steering wheel? No. And I think it's easy to go too far. Particularly, like actually my dad nearly died from clinicians with alert fatigue dismissing his heart alert going off in the same emergency department where I used to work, so they were my colleagues even. And so that's a very real risk, even with simple alerts on an outpatient setting, like Grace is at risk for preeclampsia, Grace is at risk for 1, 2, 3, 4, 5, 6, 7. So it should be incorporated for ministries. Many of us are painfully aware of the PEPFAR phenomenon with the MER indicator reports, how the requirements always grow, and then the burden on the clinicians grows to a really extreme degree. And there is a risk that we'll run into the same situation with decision support rules, just overloading the clinicians. So I would say there's two groups that are responsible to work with this. On the most important one being the Ministry of Health. I think it's too easy to accept too many rules. So being really aggressive with saying, do we really need this one? And then the second is the implementers themselves, the vendors that roll it out. Right now, one of the weird positive side effects of the custom way that decision support has been built into many systems like OpenMRS is that because it's a little tedious, the decision support alerts are few. And in some ways that's bad, and in some ways that's good, especially for a complex patient. You don't want the critical stuff to be buried under basic stuff. So I would say that the consensus on how we prevent that isn't quite there yet, especially once you start adding multiple guidelines. So now you've got the ANC guideline, the HIV guideline, the immunization guideline, and they all have some overlapping content. So it is something that ministries should be sure, to your point about collaboration, set aside time specifically for this to make sure that there's not too much going on for a clinician. Does that answer your question okay? Thank you.
Okay. Yes. That my questions. It's that OpenMRS is developed with Java language, and everyone go to Python. Is there any solution to moderate this two language? Because I know that Python have a big weight now in community development. And my second question is to my developer, big one. That's can we do something like cross-platform to have adaptation between iOS and Android? That's it. Thank you. My name is Ramdan.
Thank you. I can take the second question first, and then we'll go to Grace. So currently, we don't have support for multi-platform in Android Fire SDK. We have been looking at some options, and I think at the moment we feel like there's a lot of technical difficulties to get a lot of the advanced capabilities to work everywhere. But we are sort of keeping an eye on this in this space. And one thing that I think might be promising is the Kotlin multi-platform technology. So we're beginning to do some explorations on that. But there's a lot of technical sort of complexities around it, and especially given there's a lot of dependencies that's in Java or Android. So we'd have to see how that sort of really pans out when KMP becomes more sort of mature. But there are other solutions. There are sort of Flutter libraries as well out there using Fire. So I think if you are looking at implementing a specific solution, I really recommend that you take a look at the available libraries out there. Thank you. Grace?
Thank you. Sorry, let me clarify the question. The question was about English language or CQL or programming language? Oh, okay. For OpenMR specifically? How do you moderate between the two languages of Java and Python? Because Python is fast. Okay. So you're asking for programming language choices. So right now, the OpenMRS backend is Java, and the front end is JavaScript. But something unique about the front end that makes it easier to add new modules is that we use micro front ends, which is like microservices for the front end, which means that we also use an architecture that can support, even though we're primarily React, it can support other JavaScript languages or frameworks as well. So plug and play that way. In terms of like in this ecosystem, sorry? Yeah, exactly. You can use REST API in this ecosystem. I think the nice thing about Fire is that, and CQL, is that they're programming language agnostic. It doesn't matter that we're Java and JavaScript in order to implement this stuff.